Okay, hello guys, welcome to my YouTube channel. Thank you for always watching my video and thank you for subscribing as well. Today we'll be talking on integration, indefinite integral, the indefinite integral of 4x plus 1 over square root of 3 minus x squared dx. We are asked to solve the integral of 4x plus 1 over the square root of 3 minus x squared dx in respect to x. First of all, I would love to let you know that we can actually break this down by saying this is the integral of 4x over the square root of 3 minus x squared plus 1 over the square root of 3 minus x squared, then your dx. We can as well say this is equal to the integral of 4x over the square root of 3 minus x squared dx plus the integral of 1 over 3 the square root of 3 minus x squared dx. Now we can actually find the integral of each, and after all we sum them together to have the whole integral. How can we actually solve this integral? We can solve this by the u substitution method by saying for solving this, we say let u equals the square root of 3 minus x squared. By using the chain rule in this, we know this is 3 minus x squared in a bracket raised to the power of 1 over 2. By using chain rule, after solving, you should have du equals to x over the square root of 3 minus x squared, then your dx. Remember, u is equals to the square root of 3 minus x squared, and that is same thing here. So we can say this is equal to du. This implies du is equal to negative x over u dx. Yes, dx. Now we can find our dx from here by saying dx is equals to u over x du. You should understand this. Dx, this goes to this place, which is u, dividing by x. Dividing by negative x, you have x. Your negative sign comes up and your du. So dx is equal to negative u over x du. So from there now, we say we now have the integral of 4x over u. Then the dx should be negative. We bring out the negative from the integral. Negative u over x du. Now we can cancel out the u from the integral and as well the x. So then we have the negative integral of 4 du. What that tells us is that we have minus 4u. And what is our u initially? Our u was the square root of 3 minus x squared. So after integrating the whole of this, we got minus 4 root 3 minus x squared. And that is not the final answer. We have to integrate the whole of this as well. So integrating 1 over the square root of 3 minus x squared dx. This is like a standard integration, a standard integral, where we know from here that the answer to this integral is the sine inverse of x over the square root of 3. But we can actually show that for those that does not know how they got the sine inverse of negative of x over root 3. Now by showing that, I would rewrite this integral as 1 over the square root of 3 in bracket 1 minus x over square root of 3 squared. You should get this as well. I factor out 3 from this. Factoring out 3 from this, I got 1. Factoring out 3 from this, I got x squared over 3. And I can rewrite x squared over 3 as x over square root of 3 all squared, because now when you open this bracket, you see that you got your x squared over, then you know square root of 3 raised to power 2 is same thing as 3. So you got your x squared over 3 back. So from this is the x. We say this is equal to 1 over root 3, the integral. We bring out this root 3 from the integral of 1 over 1 minus x over square root of 3 squared dx. Now from here, we would say, because this actually looks like like what we know from trig, we know that 1 minus sine squared theta is equals to cos squared theta. So we can actually change the whole of this to sine theta by saying x over the square root of 3 is equals to sine theta, so as to make the whole of this bottom equals to cos theta. We are going somewhere, so differentiating this, we have that 1 over root 3 dx equals to cos theta d theta. So now we should find the x from here. The x from there is the root 3 of cos theta d theta. Now exchanging x for the things with theta, we see this is 1 over root 3, the integral of, instead of the x, I will write the square root of 3 cos theta d theta all over 1 minus, instead of x over root 3, I would exchange that for sine theta, and this is the square, so that is sine theta squared, all squared. So this is equal to, now we can bring this out. Bringing this out, we know this cancel out this, right? And for you that from trigonometry, we know that cos, I'm really sorry, this has the square root, and this already has the square root. This has the square root. So we already know from trigonometry that, and this has the square root. We already know from trigonometry that cos squared theta plus sine squared theta equals 1. So cos squared theta is equals to 1 minus sine squared theta. So taking the square root of both sides, we know that cos theta is equals to the square root of 1 minus sine squared theta. And this is the square root of 1 minus sine squared theta. What that tells us is that this is the same thing as cos theta. And this can cancel out just like that. And now we have the integral. This is already 1, and the inside is as well 1, and this is the theta. So we are integrating 1 in respect to theta, and that should be equal to theta. And we should know that our theta from here, by taking the sine inverse of both sides, we know that theta is the sine inverse of x over root 3. So now the total answer for our integral, which is the integral of 4x plus 1 over root 3 minus x squared dx, is equal to this whole integral, which gave us negative 4 root 3 minus x squared plus the whole of this integral that is already here and gives us this, which is sine inverse of x over root 3 and plus our constant. So this is the answer to the question, the integral of 4x plus 1 over root 3 minus x squared. You should know that the integral of 1 over square root of a squared minus x squared or b squared is equal to sine inverse of a over b. And that is why we had the sine inverse of x over square root of 3 as the answer to this integration. So thank you for watching my videos. I really appreciate it.